look here, we are trying to understand the methods by which we solve a difference equation framework. Now, while we are discussing the difference equation framework, we are considering first order difference equation. An important variable involved in this kind of model is a time variable. So when I am talking about first order difference equation, actually there will be one period time lag in our framework. So time is an important variable, and the order of the difference equation will be determined by the time lag. Okay, so if there is a lag adjustment within one period, in that case, we will call it a first order difference equation. By this time, we have understood our objective is to find out the time path of an economic variable. This economic variable may be income, saving, investment, price, unemployment, rate of interest, etc. So for any economic variable, keeping the economic feasibility in our mind, we will like to derive the time path of that economic variable. That is how this economic variable changes over time. How this economic variable changes over time. Now, what is the definition of time here? Time is discrete in nature. In reality, all of us have knowledge that time is a continuous variable. However, for the time being, to understand the essence, at least at a discrete juncture, we have started with a framework where we are considering time changes after few times, or there will be change in the phenomenon or economic variable after certain time period. Okay, so time is discrete in nature. It is first period, second period, third period, like that. Between first and second period, we try to guess that economic variable remain unchanged. Coming at second period, there may be some change. However, between second and third, there will be no change. Coming at third, there can be any change. So number one, we have time variable in our analysis. Number two, this time is discrete in nature. Number three, we are considering one period lag in the time variable. So keeping these three concepts in our mind, we are trying to find out time path of any variable using the first order difference equation technique. Now, coming to the first order difference equation technique, there are two parts: the complementary function part and the particular integral part. Particular integral is nothing but the value of intertemporal equilibrium of the concerned economic variable. So if it is income, it is intertemporal equilibrium income. If it is price, it is intertemporal equilibrium price. If it is savings, it is intertemporal equilibrium savings, etc. So PI, that is the notion of particular integral, is equivalent to intertemporal equilibrium. The idea is I'm starting from an off equilibrium position, and historically there is a concept of equilibrium. Equilibrium will be this value for a specific market. If I consider the price, if I consider the economy, it will be the income. Okay, so historically, or considering the context, there is some equilibrium. I am starting from an off equilibrium position. The derivation of time path will show me whether over time, at least I'll be able to reach to that ideal situation, or never I will be able to reach at ideal situation. Okay. So there is an ideal situation which we are calling equilibrium, which we are calling particular integral is there. Apart from this, I have to derive a complementary function. This complementary function part is very, very crucial here because complementary function consists of two unknown parameters to begin with, A and B. These two parameters have immense role to derive or to understand the nature of the time path we are considering. As you know, the complementary function we consider as a b to the power t in this format. Okay, a b to the power t format. We consider the complementary function as a b to the power t format. Okay, so if I consider the complementary function as a b to the power t format, the question is, what is the role played by b? What is the role played by a? So these questions came to me, you know. Now, if I start with this example, you know, and if I consider yt is equal to ab to the power t is our trial solution, okay. In this particular framework, we have yt and yt plus 1. Actually, if yt is equal to ab to the power t, yt plus 1 is ab to the power t plus 1. So we are putting these values in the given equation and trying to find out the value of b. Okay, once we find out the value of b, we put these value in our complementary function. So initially, to begin with, it was a b to the power t. Now the b value is 5, so we are writing it as a 5 to the power t. Pi, you know, as you understand, is the equilibrium value. So what we do, we put yt is equal to yt plus 1 is equal to ye. And from the given equation, we try to find out this ye or the equilibrium value. In this case, minus 1 by 4 is this kind of equilibrium value. So once we have the trial solution a 5 to the power t and the pi minus 1 by 4 in our hand, we put these values, you know, like this, you know, and get the required time path of the economic variable. So in this specific example, the time path of the economic variable is given by yt is equal to a 5 to the power t minus 1 by 4. Then we are telling that this equation 3 consists of one unknown factor or arbitrary factor a, you know, and therefore we have to derive the value of a. Now to derive the value of a, we consider the initial condition, okay. So we consider t is equal to 0. So we rewrite the equation using t is equal to 0, okay. Now in equation number 3, if I put t is equal to 0, we are getting this format. 5 to the power 0 is 1. So we are getting this value. And from there, we are getting the value of a, which is given by 2. So if I write the final form of the time path, it is becoming yt is equal to yt is equal to 2 5 to the power t minus 1 by 4. Yt is equal to 2 5 to the power t minus 1 by 4. So this format we are getting. So mechanically, I hope everybody could solve this kind of thing and, you know, find out the time path of the concerned variable, okay? However, some students have some doubt. Now, what is the role of these 2, 5, that is what is the role of A and B, etc. Now, to understand that, please once again look at this particular stability condition, okay? Now, once we get the time path, you know, one objective of doing this kind of exercise is to find out the time path, as I mentioned. Now there is another objective. Once we get the time path, we need to analyze the nature of the time path. We need to analyze the nature of the time path. Now, what is the meaning of nature of time path? Nature of time path indicates two aspects. The first aspect is whether over time the time path is moving towards the ideal value, equilibrium value, or not. Because always we are starting from off equilibrium position and we are trying to judge, or look at the phenomenon whether, there is a chance that we will move towards the ideal situation or not. We will move towards the equilibrium or not. Okay. So one aspect of the nature of time path is whether starting from off equilibrium position over time, we can move towards the equilibrium position. This is the first question. The second question is if we move towards equilibrium or we move away from the equilibrium, whether there will be a continuous increase or decrease, or there will be a kind of rotation, increase, decrease, in this way. Okay. In other words, whether the time path is monotonic or whether the time path is oscillatory. Okay. So once we derive the time path, the next question is, what is the nature of time path? This question has two subparts. Whether starting from off equilibrium, we can move towards equilibrium or not. Second part, whether the time path is oscillatory or whether the time path is monotonic. Okay, so this is the background. So first part, I hope everybody could do, and understand the matter. That there are some questions, some issues related to the second part, understanding the nature of the time path. Okay. Now to understand the nature of the time path, okay, I am writing this equation. Just a minute. In this format, we know the value of A, B, etc. for a specific question. We know the value of YE for a specific question, So we know the value of A, B, YE, etc. However, I'm writing the general format of the time path. YT is equal to A, B to the power T plus YE. Everybody is understanding this is the structure of the time path. Is there any question? And you know how to derive the values of A, B, YE, etc. So is there any question regarding how we derive A, B and YE? Anyone? Raunak?
No, ma'am.
Any question regarding derivation of A, B and YE?
No, ma'am.
Anurag, any question regarding derivation of A, B and YE?
No, ma'am.
Okay, so everybody is happy with the derivation of A, B and YE. Derivation part is fine?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Okay.
Yes,
So
ma'am.
now this thing. Okay. So when we are studying the nature of the time path, as I mentioned, so first question is whether this is the first question. Okay. And the second question is, okay, so these two questions are there. Okay, now I'm using a different color. So to address the first question, starting from any off equilibrium position, okay, now how we are writing this thing? I'm writing yt will move towards ye as t tends to infinity if and only if absolute value of b is less than 1. Now, given a is a constant, if you focus on this part, if b is a positive fraction, or better to say, if the absolute value of b is less than 1, in that case, if you consider t is equal to 1, suppose it is half, it is half. If t is equal to 2, it is 1/4. If t is equal to 3, it is 1/8. If t is equal to 4, it is moving like this, okay? 1/16. So the value is continuously reducing and reducing. If absolute value of b is less than 1, in that case, as you increase the power t, b to the power t, that continuously reduces and that moves towards 0. So given a is a constant, if power, that means t increases, okay, if mod b is less than 0, as the power t increases, b to the power t, that moves towards 0, and hence the entire ab to the power t, that moves towards 0, this entire term moves towards 0, which indicates yt moves towards ye. This in turn indicates yt moves towards ye. So whether the time path will be stable or not, that is whether the time path will be convergent or not, or whether the time path will be convergent or divergent, that will be determined by the absolute value of the parameter b. Parameter b. The time path will be convergent or divergent, that will be determined absolutely by the absolute value of the parameter b. If mod b less than 1, as t tends to 0, a b to the power t, the entire term in the right hand side entire first term in the right hand side moves towards 0, and as a result yt moves towards ye. Okay. So those who have question, are you understanding the role of B here in understanding the nature of the time path?
Yes, ma'am.
Understanding? Okay. Now, this is the first role played by B. B has a second role too. This is only the first role played by B. There is a second role which will be also played by this parameter B. Now, what was our second question? Whether the time path will be monotonic or oscillatory. Okay. Now, if we consider the actual value of B, not the modulus value. Now, if the actual value, let me use a different color. So now I am going to address question number 2. Now we will not consider the absolute value of B, rather we will consider the actual value of B. So let me go back to the equation. In this equation, A is still a constant. Now, if this B is positive, in that case, both for the even and odd power, the A, B, or say B to the power T, that will remain positive. Both for the even and the odd power, B to the power T value, that will remain positive. However, if this B is negative, in that case, for the odd power, this B to the power T is negative. However, for the even power, this B to the power T will be positive. For the odd power, the value will be negative. For the even power, the value will be positive. Okay. Again, I am repeating. If B is positive, in that case, both for the even and odd power, the direction of B to the power T will remain same. However, if B is negative, then for the even and odd powers, the directions of B to the power T will change. For the negative values, it will move to one direction. For the positive value, it will move to the other direction. Okay. So there will be directional changes in B to the power T component if B is negative. To clarify this context once again, we will say that if B is positive, in that case, the time path will be monotonic, unidirectional, monotonic. On the other hand, if B is negative, the time path will be bidirectional, positive, negative, around YE value, it will move up and move down continuously. So if B is negative, you will get bidirection depending on the power T, even or odd. If B is positive, you will get unidirectional. It will remain either above YE or it will remain below YE. Okay, it will not like, above and below, it will be not like this. Okay, so you will not get this kind of cyclical movement if B is positive, and you will get cyclical kind of movement when B is negative. Okay, so B has a second role. And okay, so exact nature of the time path will be determined by B. Whether it will be convergent, divergent, monotonic, oscillatory, everything will be determined by the component B. So B is very, very crucial factor in determining the time path of the economic variable. Those who thought that B has actually A and B has no role to determine the time nature of the time path, I hope they are understanding B is determining the entire nature of the time path. First, it is deciding whether the time path will be monotonic or convergent. Time path will be convergent or divergent. Secondly, it is also determining whether the time path will be monotonic or oscillatory. In the first case, we will use the absolute value of B, and in the second case, we will consider the actual value of B. So those who had confusion, so please let me know whether you are understanding the role of B in determining the nature of the time path of any economic variable. Everybody understanding the matter? Any question? Should I need to repeat any part? So everybody is understanding the matter?
Yes,
Yes.
ma'am.
Yes,
Yes.
ma'am.
Yes, ma'am.
If anyone has any question, please ask me. Ask me at this moment. Don't think that other people are understanding, I'm not understanding. Okay, don't do that.
Ma'am, I had a question. Hello.
Okay, so next,
Uh,
yeah.
Ma'am, I had a question. Ma'am, does B have any role to play in determining whether it's monotonically increasing or decreasing? Like if it's monotonic, it's like it can determine whether it's monotonic or oscillatory. But if it is monotonic, whether it will be increasing or decreasing, will B play any role in determining that?
Uh, you didn't understand the first part, convergent or divergent part.
Yes, ma'am, I did.
Okay. So convergence or divergence itself is indicating whether it is increasing, decreasing, is it?
Okay, 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 okay. Yes,
Okay. The idea of convergence is increase, if you start from initial price or value of y or any economic variable above equilibrium, and if you want to establish a convergent monotonic path, in that case you have to consider a decreasing path, isn't it? Though
yes,
it
ma'am.
is a step function here, however it will be on an average decreasing function. Okay.
Yes,
On the other hand, if you start from initial point, I didn't explain the role of A so far. Actually, role of A will be to determine whether you will start above or whether you will start from below. Okay. So if you start from below and if you want a convergent kind of thing, in that case, you have to consider a function which is increasing in nature. Okay.
yes, ma'am. Got it, got it.
And in case of divergence, just the reverse. Okay, so
Yes, ma'am.
look at the first issue, that is mod B is less than 1 or not, and understand the nature of convergence and divergence. You will understand the idea of increasing or decreasing function. Okay,
Yes, ma'am. Thank you, ma'am.
any other question?
Hello, ma'am. Actually, I have a question on the exercises that you had assigned from Chiang, 17.3.
Who are you?
Uh, Ma'am Shrishti.
I think I told you first I'll clarify the theory and then
Oh,
I'll go for the
oh,
numerical exercise. You were not there in the class?
no, ma'am, I was, ma'am, but ma'am, these are the exercises regarding the before the
I'm
cobweb
discussing
model.
the
That
theory part.
that.
I'm discussing the theory part.
Oh, oh, okay, ma'am. Yes, ma'am. Sorry, ma'am.
I
Sorry.
didn't ask any question regarding the numerical part.
No, then sorry, ma'am. I might have misheard. Sorry.
The next aspect is regarding A. Okay, the next aspect is regarding A. Now, what is the role of A here? Now, I hope many people understand, by this time, the role of A in determining the nature of the time path. Anyone please clarify what is the role of A here? Role of A. Okay, so these question 1 and 2 are addressed. Okay, so the next question, that is question number 3.
Um, it affects the shape of the path.
Shape. What is the meaning of shape?
Ma'am, A can
Blow up
the
or blow down?
blow up or pare down the value of
Blow up
the
The
or
A.
pare
starting
down
position of.
the value of b to the power t.
Now it gives a
Ma'am,
scale
y
effect.
zero value is determined.
Okay, just give me one answer. Many people said many things. So if I ask, what is the role of A? One answer, one single answer first.
It
Ma'am,
produces
if
a
it
scale
is
effect and it blows up or pares down the value of A into B to the power T.
positive, then the total value will blow up, and if it is negative,
Negative,
then
it comes down.
a b to the power t, it will come down.
No, if A is greater than 1,
Yes, if it's A greater than
yeah,
1, then they will blow
will
up.
blow up the value.
It
So
will blow up.
basically, A has two effects. First effect is dependent on the magnitude of A, and the second effect is dependent on the sign of A.
Shape
Shape
of,
of the path.
Hmm.
yeah,
And the sign of A
yes.
determines the shape of the path, while the first one, that is magnitude of A, it produces a scale effect. That is, if A is greater than 1, it blows up B to the power T, and if it is less than 1, it pares down
Pares down
power
the
T.
value.
Okay,
Uh,
everything is perfect in the last answer, apart from one fact or one wording, or that is it. A determines the shape of the time path. A does not determine basically the shape of
Sign of
the path anyway. Okay, it only determines whether we will start from above equilibrium or we will start from below equilibrium. While we discussed the cobweb model, or we will discuss some other model, I hope you are understanding A will be basically the this kind of thing. Okay, the difference between the initial value and the equilibrium value. The difference between the initial value and the equilibrium value. Okay? In case of cobweb model, if you look at the time path, it is P naught minus PE. This, for this particular example, numerical exercise, would you please check whether the value of A you are getting, this 2, this is the difference between Y naught and YE or not? If you look at this equation, what we have done, we have just took the difference between Y naught and the YE. Okay. So always the difference between the initial value and the equilibrium value is the value of A. Everybody is understanding this matter? The difference between the initial and the equilibrium value is nothing but the parameter A. First tell me this thing. Is it clear? A is equal to the
Yes,
initial
ma'am.
value minus the equilibrium value, be it a numerical thing, be it cowboy, be it something else, you know. This A has an interpretation. The interpretation is, it is the difference between the historically given value, that is the starting value or the value at 0th period, and the equilibrium value. Is it acceptable? Is it understandable to everyone? A is the difference between the initial value and the equilibrium value. Everybody is understanding this? Any question regarding this? So people are understanding or not, that I am not understanding.
Yes, ma'am. It's clear.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
so if you understand, please let me know whether you are understanding or not, okay? Because I'll be not able to address, you know, the questions regarding the role of A and B once again through your mail. So it's better to clarify everything in today's class. So if this is the thing, and if I consider this to be, say, Y, okay, be it oscillatory path, be it monotonic path, you know, I should have a starting point, you know. So if A is Y naught minus YE, actually A is determining this or this kind of starting point. Okay, this kind of starting point, because if it is a monotonic path, continuously I'll come towards YE. If it is divergent monotonic, I'll continuously move away from equilibrium. That's true. However, I have to start from certain position. So Y naught minus YE, or the value of A, will determine from which point I'll start. From which point I'll start. Okay, so it is giving us this kind of starting point. If is greater than 0, then I'll start from this point. Now if it is oscillatory, I'll come like this, etc. If it is monotonic, I'll move like this, etc., or move away from equilibrium, etc. Okay. However, if Y naught minus YE is less than 0, Y naught minus YE less than 0, in that case I have to start from a point like this, you know. Then if it is oscillatory, I'll move like this. If it is monotonic, convergent, I have to move towards equilibrium. Divergent, move away from the equilibrium. However, every time path has a starting point. Now where this starting point will be located, that will be determined by this A. If A is positive, we will start from some point which is above equilibrium. If A is negative, we will start from some point which is below equilibrium. Okay, so A determines the starting point. A determines the starting point. A positive, start from a point which is above equilibrium, then it may be monotonic, oscillatory, convergent, divergent, whatever. If the value is negative, you have to start from a point which is below equilibrium, and in that case again the time path may be oscillatory, convergent, oscillatory, divergent, monotonic, convergent, monotonic, divergent. Anything is possible. Okay. So the first role of A is it determines the starting point. It determines the starting point. Just let me. Okay. Now the second role, as you mentioned, it has some scale effect. Now, if y naught minus ye, this value may be 5, 6. Suppose I am considering positive value of a. Okay. So suppose this value is 5. Any value. So, in this diagram, I'll start from this point, say. And if it is a monotonic convergent time path, it will be like this. Next, consider this value is say 2. In that case, the same type of time path I am considering. However, my starting point is quite close to that of ye. Okay. So it has a scale effect too. Higher the value, the distance between ye and the starting point will be higher. Lower the value, the gap between yt and ye will be lower. So in that sense, it is not disturbing the basic nature of the time path. That will be determined by B solely. That is whether it will be convergent, divergent, monotonic, oscillatory. These will be totally determined by B. And no way it will affect this particular nature of the time path of the economic variable. However, A changes the scale. Okay. If the value is high, your starting point or gap between the starting point and ye will be quite higher. And if the value is smaller, in that case, you will start from a point which is very close to that of ye. Okay. Now, instead of +2 and +5, if the values are -5 and -2, the same thing, you will start from this point. Minus is telling you your starting point will be somewhere below the equilibrium. And if the value is 2, the nature of time path will not change. Only there will be some change with respect to the scaling component, the scaling component. So this is the idea. So A will not change the nature of the time path. Rather, it will add a scale effect in the time path, and it will determine from where to start. We will start from a point which is above equilibrium, or we will start from a point which is below equilibrium, etc. So these are the vital roles played by A and B in understanding the complete nature of the time path. A does not determine the shape of the time path. A determines the starting point and naturally the scaling issue. B determines the shape of the time path: monotonic, oscillatory, convergent, divergent, etc. Any question regarding roles of A and B? Any question, any kind of question, please ask me. Once you understand this general issue, this issue is applicable for any kind of applications we will consider. Be it a cobweb model, be it inventory model, be it any kind of model. Is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, so I'm erasing the entire thing. And coming back to the cobweb model, in case of cobweb model, B is beta 1 by beta 2, and A, as you got, P naught minus PE, and therefore the shape of the time path is PT is equal to P naught minus P, beta 1 by beta 2 to the power T plus PE. This was the time path. And everything I discussed in general is applicable for this kind of cobweb time path of price where we are using the cobweb model. Okay. So I think I could complete, 3 oscillatory varieties, and I could not complete the monotonic time path part. Am I right?
Yes, ma'am.
So any question up to this? Anything? Anyone? Anyone, any question for the cobweb model? Okay, so I'll move for monotonic time paths. So to get the monotonic time paths, either I can consider both the demand and supply curves are negatively sloped, or I can consider both the demand and supply curves are positively sloped. Okay. So this is a particular specific diagram, where I have considered both the demand and the supply curves are positively sloped. Now, in your copy, please write down the stability conditions, this condition. Beta 1 less than 0, beta 2 less than 0. That is, I am considering this particular case. Both the demand and supply curves are negatively sloped. Now, what is beta 1? Anyone? What is beta 1?
Slope
It is
of the supply.
Slope of the supply curve.
Slope
slope
of
of the
supply curve.
beta 2 is the slope of the demand curve. Okay. Okay. Along with this, please write down modulus of beta 1 is less than modulus of beta 2. So please write down this case for, or this condition for, beta 1 less than 0, beta 2 less than 0, mod beta 1 less than mod beta 2, mod beta 1 less than mod beta 2. Sorry. So okay, and as you mentioned, slope of supply curve, and this is the okay. So if you look at the mathematical condition, what we need that absolute slope of the supply curve less than absolute slope of the demand curve, isn't it? Everybody, the mathematical condition is showing us absolute slope of the supply curve is less than absolute slope of the demand curve. Am I right?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Now to present this condition graphically, what I have to consider, just the reverse of all these things, because in the horizontal axis I am measuring quantity, while along the vertical axis I am measuring the price. So to match with this case 4 or this condition, what I have to consider, 1 upon mod beta 1 and 1 upon mod beta 2. Okay, so mod beta 1 less than mod beta 2 indicates 1 upon, sorry, mod beta 1 greater than 1 upon mod beta 2. Everybody, 1 upon mod beta 1 greater than 1 by mod beta 2. Am I right? Modulus beta 1
Yeah.
less than modulus beta
Yes,
2
ma'am.
Yes,
indicates
ma'am.
1 by modulus beta 1 greater than 1 by modulus beta 2. Okay. Now 1 by modulus beta 1, that will be my slope of the supply curve graphically. And 1 by modulus beta 2 will be my slope of the demand curve graphically. So in my graph, supply is steeper than the demand curve. Supply is steeper than the demand curve. Look, blue line is the steeper than the red line. Red line is the demand curve, whereas the blue line is the supply curve. Okay. So look at the condition, and when you will draw the graph, you have to follow to maintain, the mathematics, or the mathematical condition. You have to consider the inverse position, because I have changed the axis position. I'm considering price along the vertical axis and quantity along the horizontal axis. Okay. So if you follow this criterion, which you already did in case of Walrasian and Marshallian context, in that case, there will be no mismatch between the mathematical part and your graphical part. Okay. Just the reverse of the mathematics you should consider when you will consider your graphical part. Now, if this is the condition, look at this diagram. If I start with this position, if I start with this particular price, there is an excess demand. If there is an excess demand, price will go up. Price is going up to this. There is an excess demand, means, the supply is at this point. If you look at the diagram perfectly, actually this is the market supply, while the demand is this much. So there is an excess demand. So since this is the first quantity, the price will go up following this particular quantity. So this will be the next price. Now, at this price, this is the supply and this is the demand. At the higher price, now supply is not up to this. At the higher price, supply is only this much, while demand is this much. So still, there is an excess demand, so price will go further up. Now, as price is going up following the supply quantity itself is changing. It is reducing to this level. So again, there is an excess demand, and so price will go up, and eventually it is moving towards the equilibrium. So starting from an off equilibrium position, in this particular case, price is going up and up towards the equilibrium level. So here we are getting a monotonically convergent or divergent time path.
Convergent.
Convergent.
It's convergent.
Convergent time path, because we are moving towards
Monotonically
equilibrium.
convergent.
is monotonic because there is no fluctuations. It will not move up and down the equilibrium. Since both beta 1 and beta 2 are negative, the ratio beta 1 by beta 2, that is positive. In our cobweb time path, the value of small b, that is given by beta 1 by beta 2. Okay, so this beta 1 by beta 2, when both beta 1 and beta 2 are negative, is positive. Okay, so there will be no fluctuation above and below equilibrium. Rather, continuously here we are getting the price is moving up and up and up towards the equilibrium. However, depending on the value of A or depending on the value of P naught minus PE, your starting point may be like this. It may not be like this. Your starting point may be like this. In this particular case, the demand is this much and supply is this much. So there is an excess supply. So if there is an excess supply, there will be a reduction in price. As the price is reducing, the demand is given by this much, whereas supply is again given by this much. So still there is an excess supply. So price will again fall and eventually it is moving towards equilibrium. So if I start from this position, depending on value of my P naught minus P, then also I am finding that it is unidirectional, that is, it is monotonic in nature, and it is convergent because it is moving towards equilibrium. So please draw this diagram. Should I need to draw the diagram with you? Or is it fine to all of you? You will be able to do it, or already you are doing this?
It's fine, ma'am.
Able to do
Fine,
an
ma'am.
Yes, ma'am.
And while you are, please understand all these issues. You started with mod beta 1 less than mod beta 2. However, you are drawing a steeper supply curve and flatter demand curve because you have to consider 1 upon mod beta 1 and 1 upon mod beta 2 while you are drawing the diagram. It's fine with all of you. Should I move to the next slide? Could you complete it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And understanding the quantities, prices, last day some students found, how we are getting these things, how we are understanding the quantities. Actually, everywhere quantities are there, okay? So basically this is demand, supply, this is demand, this is excess demand, then it is moving like this, and then there is this quantity, So quantity and not extending up to the axis, that's all. However, for each layer of price, there is a quantity demanded, quantity supplied, etc. Avishikta, do you have any question?
No, ma'am, it's fine.
Okay, so if I like to draw the time path of price, against time, if I draw the time path, as I mentioned last class, actually you can draw the axis. If you like, you can draw this axis too. And these are all P naughts, P naught. So this can be your starting point. So it can be like this. And this can be also your starting point. So it will be like this. So along the vertical axis, we are measuring PT. Along this direction, we are measuring time. And this is particularly PE. So these are the time paths: monotonic, convergent time path of price. For this typical case, we are getting monotonic, convergent time path of price. Done? So I'll move to this case. Case 5. Please write down beta 1 less than 0, beta 2 less than 0. So both the curves are negatively sloped. However, mod beta 1 greater than mod beta 2. Mod beta 1 greater than mod beta 2. Okay, so everybody written these things: beta 1 less than 0, beta 2 less than 0, mod beta 1 greater than mod beta 2. So please do this thing on your own. Both the demand and supply curves will be negatively sloped. However, you should be very careful about the elasticity of the demand and supply, whether the demand curve will be steeper or whether the supply curve will be steeper. So everybody could write this case 5, what you need to do: beta 1 less than 0, beta 2 less than 0, mod beta 1 greater than mod beta 2.
Yes, ma'am.
Yeah, ma'am.
Okay, so now you do this thing. Do this thing on your own. Please do it. So please let me know when you will be able to finish it. Once you finish it, please let me know. First, you draw the cobweb structure only, and after that, you will draw the time path. Once you complete the cobweb framework, please let me know. Done?
Done, ma'am.
Yes, ma'am.
Yes, ma'am.
Ma'am, it's done.
Okay, so Deepika, could you complete it?
Yes, ma'am.
Okay, so would you please present it?
Okay, ma'am.
Closing my presentation, please present yours.
नीचे लाइट चालू करना है जल्दी
Uh, which one? This one. Yeah. Okay. Yeah. Yeah. Just fix it like this. It's very clear. Okay. So this is the demand curve. So from where we started, beta.
Ma'am, from this.
Yeah. Okay. Okay. And continuously we are moving away and away from the equilibrium. So while we are drawing the graph, demand is steeper than supply.
Yes, ma'am.
Okay. So everybody did the thing in this way.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So
Yes,
is
ma'am.
there anyone who did it in different way? Okay. And so I hope you will be also able to draw the time path.
Yes, ma'am.
Okay. So
Yes, ma'am.
yeah, it will be continuously move away and away from the equilibrium. So please do that. Yeah, Deepika, thank you.
Okay, ma'am.
Very good. So this is the case. If anyone has any question, please ask me. Please add P naught, PE, and you can add the horizontal axis. Actually, along the horizontal axis, we are measuring T. The solid black horizontal line is nothing but the equilibrium price PE. So mark the things accordingly. So just two cases left. So both the demand and supply curves may be positively sloped, both beta 1 greater than 0, beta 2 greater than 0, and mod beta 1 less than mod beta 2, and mod beta 1 greater than mod beta 2. Okay. So apart from the 5 cases I mentioned while I covered the theory, there are 2 more cases. Both the demand and supply curves are positively sloped. Okay. So please add one sixth case, case 6. Beta 1 greater than 0, beta 2 greater than 0. And mod beta 1 less than mod beta 2. So actually I'm following case 4. Apart from considering beta 1 and beta 2 negative, I am considering beta 1 and beta 2 are positive. So I'm doing case 4. Beta 1 greater than 0, beta 2 greater than 0, mod beta 1 less than mod beta 2.
Monotonic.
Did it? So please check what will be the nature of the time path in this case. Draw your diagram.
Ma'am, monotonically convergent.
Hmm? Please let me know. I just could not understand.
Ma'am, can you show that diagram once again? In monotonically divergent, case 5.
Case 5.
Ma'am, it's the one which you told us to draw right now, and
Case 5, you could not complete case 5, Udita.
yes, ma'am, I did, but I want to check if I did it correct.
Okay, and what about case 6?
Ma'am, monotonically convergent.
Yeah.
Monotonically
I'm Udita, could you start drawing case 6?
Case 6.
We are doing case 6 now. Because we are considering both demand and supply curves are positively sloped. Because here we are doing a case when beta 1 greater than 0, beta 2 greater than 0, mod beta 1 less than mod beta 2. So Udita, right now what you are doing?
Ma'am, I was just busy doing case 5, so I wanted to see if I did it correctly.
And case 6 you did or not did?
Ma'am.
Yes or no?
Oh, ma'am, case 6 not done. I have started drawing case 6.
Okay. So this is the diagram for case 5. Okay. This I am presenting only for Udita because she said she needs to check it.
Yes, ma'am. Yes, ma'am. Done.
Done? Okay. Next, Sneha, roll number 2. Have you
Yes,
diagram?
Number 6.
Yes, Sneha, would you please present it?
Yes, ma'am. Ma'am, this is number 6.
Your understanding. একটু fix করে ধরো, please. Both the demand and supply curves are positively sloped. It is very clear. And which one is steeper? It is steeper.
Supply curve.
Would you please fix it in front of your camera? যেরকম রেখেছিলে খুব ভালো দেখা যাচ্ছে, তুমি জাস্ট একটু ফিক্স করো। স্নেহা,
Yes, ma'am.
your audio is disturbing a lot, but camera is very good. Okay. So everybody, please fix it like this. So everybody, please check whether you got this kind of diagram or not. If you got this one, it is fantastic. It is perfect.
Yes, ma'am.
So is there anyone who need to check it once again? From Sneha?
ম্যাম এটা ডাইভারজেন্ট হচ্ছে না?
এটা ডাইভারজেন্ট হচ্ছে, এটা তো কনভার্জেন্ট হচ্ছে।
ম্যাম, যে প্রবলেমটা যেটা হচ্ছে যে যখন আমরা মানে নিচের পোর্শনটা কনসিডার করছি তখন তো এক্সেস সাপ্লাই হচ্ছে। এক্সেস সাপ্লাই হলে তো প্রাইস ফল করবে, তো ওটা কনভার্জেন্ট কি করে দেখাবো?
তুমি তুমি ইনভার্স স্লোপটা নিয়েছো?
হ্যাঁ ম্যাম, সাপ্লাইটা বেশি স্টিপার অ্যান্ড ডিমান্ডটা ফ্ল্যাটার। তো সেইটা যদি আমি করি আর কনভার্জেন্স দেখাতে হয়, আমি যদি নিচের পোর্শনটা কনসিডার করি একটা স্ট্রেট লাইন ড্র করে, তখন এক্সেস সাপ্লাই হচ্ছে। তো ওই দিকে তো আমরা তাহলে ইকুইলিব্রিয়ামের দিকে টেন্ড করব না, কেন কি এক্সেস সাপ্লাই হলে প্রাইসটা ফল করবে।
লেট মি চেক।
Yes, ma'am, it is coming as divergent.
Okay, let me check.
Yes, ma'am.
Theoretically, it should be
Divergent.
convergent,
It's moving
but
away from the
yeah,
equilibrium.
yeah.
Graphically,
Let
it
me
is
check
coming divergent.
whether there is any issue or not. Yeah, it is like this, na?
Yes ma'am, it's like that.
Yes, ma'am.
Yes, ma'am. So it's not stable.
Yeah. So there is some problem if I look at, if I try to check the cases with the positively sloped supply curve. Okay. So in this direction, if I look at this part, true, there is an excess. Let me check. There is an excess supply. So price is falling. And if there is this part excess demand, so the thing is moving towards equilibrium. Okay, so I think we will be not able to establish the cobweb theories perfectly when the curves are positively sloped. Okay, so we will not go for that. Okay, we will not go for that. Just I told you to check all these things, you know. And as several students have pointed it correctly, you know, if you look at these things, in one part it is happening in one way, in other part it is happening in other way, you know. So if your starting point is something, you will get some picture, whereas your starting point is something else. In that case, you will get the reverse picture. Okay, so we will not proceed further using the models where both the curves are positively sloped. We will be not able to derive any consistent result if I consider both the demand and supply curves are positively sloped. Okay, so we will concentrate only with these 5 cases in context of cobweb models. Okay, we will concentrate only with these 5 cases when we are discussing the cobweb kind of framework. So if I consider positively sloped curves, we will be not able to establish the theory consistently. Okay, so this is all about the cobweb model, how what will be the nature of the time path, what will be its stability analysis, etc. And now we have to discuss a number of numerical exercises so that you understand the matters well. So today I'll start discussing one numerical exercise and then I'll continue it in the next class. Any question from any part of the theoretical section of the cobweb model?
Yes, ma'am. I have a question, ma'am Srishti. Ma'am, in the last case, ma'am, that is case 6. In the upper part, you were saying that it is coming back to equilibrium. Then, the towards the right of the equilibrium. Yeah. Yes, ma'am. In the right, ma'am. So, yes, ma'am. In the right side. So here the demand is again excess, right? So why is the price falling? Like I understood the left side.
Demand, there will be a reduction in price. This is the standard mechanism. And if there is an excess supply, there will be an increase in price. Sorry, there will be a reduction in price.
Yes, ma'am. But yes, ma'am. So that I've understood that in the left side of the diagram that there is an excess supply, so the price will fall, and we are moving away from the equilibrium. But ma'am, if the demand is more than the supply, then the price should be rising, right? Like there is an excess demand in the right side of the model.
There is some
Like
problem with the arrows.
yeah, yes, ma'am. That is what like over that side also it should move away from the equilibrium because there is excess demand. So I didn't understand that part well.
let me do it. Which one will be steeper?
Ma'am, it's a supply curve.
Supply curve.
Supply.
So green one will be the demand. Let me do it also. Green one will be the demand in our case. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. And if I consider this kind of price, so there is an excess demand. Price will go up. Further, if this is the price, excess demand, and price will go up further, etc. Okay. And if I start from this position, excess supply, so these are roughly the cases, right? So we are getting monotonic divergent kind of thing.
ম্যাম নিচের দিকে তো কনভার্জেন্ট হবে না, because ম্যাম if there is excess supply then the price will fall. Yeah, okay ma'am, I got it.
No, it's fine.
Yes ma'am.
Excess, yeah. Excess supply, price is going down, down and down. Okay. So what we are finding that monotonic divergent time path of price. Now we considered the condition beta 1 by mod beta 1 by mod beta 2 less than 1, isn't it?
Yes, ma'am.
Yes, ma'am. Beta
Yes, ma'am.
1, mod beta 1 is less than mod beta 2. So it's the entire value is less than 1.
However, whenever it is less than 1, theoretically we should have a convergent time path, isn't it?
Yes, ma'am.
Yes, ma'am.
Yes ma'am.
Okay.
Yes, ma'am.
So the inconsistency is here. Okay. So graphically, when we are putting the matter, we are getting the divergent time path. Monotonic time path we are getting. However, we are getting divergent time path. Okay. So this is creating a problem. We have considered beta 1 greater than 0, beta 2 greater than 0. And we have considered mod beta 1 less than mod beta 2, which is indicating 1 by mod beta 1 greater than 1 by mod beta 2. And this indicates supply and slope of supply. So we have done these things graphically, okay? However, it is giving us a monotonic divergent time path. So there is this inconsistency. This is the inconsistency part. Okay, we cannot have monotonically divergent time path with the condition beta 1 by beta 2, mod beta 1 by beta 2 less than 1. Okay. So Srishti, I hope now the thing is understandable, isn't it?
Yes, ma'am. Now I've understood. Thank you, ma'am.
So the results are bit inconsistent. Just a minute.
Ma'am, can I the monotonic time path for a greater than 0 here? Like how we are supposed to draw that? You showed a kink there, so you can show it at any point. The fact that there is inconsistency.
Just a minute, আমি শুনতে পাইনি তোমার কথা. Just a minute. I'm coming. হ্যাঁ, yes, একটু বলো, কিছু বলছিলে কেউ একটা? Is there any question?
Ma'am, even ma'am, when we are drawing the monotonic time path for this stable market equilibrium, which is not like correct when we are plotting it in the graph, how will we express it in terms of the graph? Will we give a kink in any point for a greater than 0, that monotonic time path? We'll just show a kink.
Your question, for which particular case you are asking this question?
Both are positively sloping. B1 greater than 0.
In both cases, we are finding that results are inconsistent. Okay. So, the two positively sloped demand or positively sloped demand and supply This particular case is giving us inconsistent results, so we will not proceed with positively sloped demand and supply curves here.
Ma'am, in case 5 also there is inconsistency.
No, there is no inconsistency in case 5. No problem with case 5. It's perfect. How you are finding inconsistency in case 5? Who are you?
Ma'am, ion.
Ion. Ion, how you got inconsistency in case 5? Case 5 is beta 1 less than 0, beta 2 less than 0, mod beta 1 greater than mod beta 2. Okay, which should give us monotonic divergent time path of price. Both demand and supply are negatively sloped, and mod beta 1 by mod beta 2 we are considering greater than 1. Then let's come to the diagram. So we are considering.
Ma'am, here there is excess supply below, so the price will fall.
Price will fall continuously, yes.
Okay, ma'am, okay. Sorry, ma'am.
Excess supply, yes, you are right. Price will fall continuously. Okay, you got your point?
Yes, ma'am, I got it.
Yeah. No problem there. Only with positively sloped cases, there are inconsistencies. So, if you look at my theoretical structure, therefore, I didn't keep it in my theoretical structure. Okay? In my theoretical structure, the case 6 and 7, that is beta 1 greater than 0, beta 2 greater than 0 are not there. You know? And you need to check why we are not considering these two cases, because we are getting inconsistent results in these two cases. Okay?
Yes, ma'am.
So now we have to discuss the numerical exercises. You know, today there is no time to discuss the numerical exercises, so I'll do it in the next class. Okay, so you don't need to do the problems based on this cobweb kind of framework. Just I told you, just a minute, I'm opening the Chiang. I told you to complete only the first order, you know, 17.3 ABCD. মানে 1 ABCD আর 17.33 ABCD. 17.31 ABCD আর 17.33 ABCD. Only these 8 problems you need to do. Okay, so is there anyone still who has problem with any one of these 4 problems, 4 numerical exercises?
Ma'am, can you just discuss the solution for 73, question number 3D?
3D.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Here, I think the value is becoming 1, isn't it?
B is equal to 1, yes.
Yeah, so if it is equal to 1, already you did, you know, this will be the case. This one, this will be the same path.
So how will we, I mean the particular integral with respect to that, how will we frame our time path?
This is the required time path.
Okay, so we'll just write that the time path will be parallel at 1 to the t-axis.
Yeah. So whenever you will get the value to be, b value to be equal to 1, you know, in that case, it will be, this is the required time path. The time path is a straight line parallel to the horizontal axis, and it is fixed at the value 1. Okay? And it is not the convergent or the stable time path, because it is not coming towards equilibrium. So it is not stable time path. Okay, I cannot say this is divergent. However, it is not stable at all. It will remain fixed at the particular level 1. Actually, when it is -1, you are getting uniform oscillations. Then also it is neither convergent nor divergent, unstable. However, neither convergent now nor divergent. This kind of situation. Here also it is unstable equilibrium. Okay, unstable equilibrium.
Yes, ma'am. The graph I understood, we all understood. But if when we are writing this general solution, the this case will be A.
This case will be,
I mean, since B is equal to 1, trial solution becomes A, B to the power T, so it becomes A.
yeah.
So how do we find this A? Just by equating it with Y naught, so it's 5.
Yeah.
Okay, okay, okay.
Just a minute, let me check.
Ma'am, what will be YP?
Just a minute. Yt is equal to 1.
Ma'am, B is 1. YT then should be technically 5.
Let me check. Let me check. So the value is yt plus 1 minus yt is equal to 3. You start,
Yes, ma'am.
and y
Yes, ma'am.
naught is 5.
5.
Yes.
Yes.
So for CF, you are setting yt is equal to a b to the power t, and b value is becoming 1.
Yes.
Everybody?
Yes, ma'am.
Okay.
Yes, ma'am.
Huh. And for pi, you are getting the value to be equal to 0.
Yes.
Yes, ma'am.
Okay, so along the axis you are getting the equilibrium. The pi
Yes.
value is equal to 0.
Yes, ma'am.
Okay, so please write down pi is equal to 0. And CF, complementary function, that is yt is equal to a 1 to the power t.
Yes, ma'am.
Yes, ma'am.
Okay, now I am writing the time path. Time path, finally the time path yt is equal to, Achha, the previous one is the complementary function. Sorry, that will be yc. Yc is equal to a 1 to the power t. CF is a 1 to the power t, and pi is 0.
Yes, ma'am.
Yes, ma'am.
Everybody. Okay, now coming to the time path, yt is equal to CF plus pi. Or yt is equal to
A into 1 to the power T.
a into 1 to the power t.
Yes, ma'am.
Okay. Now a is equal to 5.
Yes, ma'am. So YT should technically be 5.
Yes,
Yeah.
ma'am. A constant.
Yt is equal to 5 into 1 to the power t then.
Excuse me, ma'am. Ma'am, but if we put values To check it, ma'am, we get y0 is equal to 5, y1 is equal to 8, y2 is equal to 11. Ma'am, the values are increasing.
Yt is equal to 11. From where you are getting 11?
Ma'am, y2. And the,
Y2? Y2, from where this Y2 is coming? I am repeating. Please follow me. Your initial equation is yt plus 1 minus yt is equal to 3. Okay? And y0 is given at 5. Y0 is equal to 5. You are considering complementary function yt is equal to a b to the power t. So your yt plus 1 will be a b to the power t plus 1. So if you put these things in your initial equation, a b to the power t plus 1 minus a b to the power t will be equal to 0. If you take a b to the power t common, a b to the power t into b minus 1 is equal to 0. Since a b to the power t not equal to 0, your b value will be equal to 1. So your CF is equal to a 1 to the power t. Got up to this?
yes, ma'am.
Okay. So CF part is complete. Next, for the PI part, you are getting the value to be equal to 0. Because it is ye minus ye, it is becoming ye minus ye. So this is the problem here. Actually, we should have ye should be equal to something. Here, ye minus ye is equal to 3. So this is creating a problem for all of us. So this value is equal to 0. If it is ye minus ye, then it will be equal to 0. Actually, here there is the problem for the PI part.
Excuse me, ma'am. But if we take yt as a constant, then yt minus yt minus 1 will be 0.
So for this particular problem, we have nothing to do. If we really need to solve it, because intertemporal equilibrium will remain constant for the period t plus 1 and t. Okay, there will be the same value. Okay, so we have nothing to do, So the problem of this particular problem is there may be some typo, there may be some other issue, However, the problem is in solving the PI part. There may be some typological error too. We don't know.
Ma'am,
Yes.
ma'am, in the
Ma'am,
page 550 of the Chiang, there is a particular case which is describing how to solve this type of equation when b is equal to 1. There is a separate formula I found in Chiang.
No, why should we use a separate formula? Because we are applying this kind of difference equation for our purpose only, and why we will use the separate formula. Okay. However, I'll check it, Because
Yes, ma'am, because if we follow iteration, like kind of just like putting values, we are getting 1 is equal to 8, y2 is equal to 11. So it's inconsistent with the previous formula.
Yes, ma'am.
ma'am, they have termed this as moving
yeah,
equilibrium,
because there
an
are
exception
different
case.
issues and the different problems, they are putting here coming from different issues, you know. However, we don't need to do all these things because we have a typical purpose. Here we are not learning basically the difference equation in different forms. We are learning difference equation to apply it under several contexts, you know. And that is creating an issue here for this typical problem. Yes, I am understanding when we are going to solve the PI part, there will be some difficulties because here YE minus YE kind of thing is coming, you know. For the economic problems, you know, this kind of issues will never appear. So, you know, YE minus YE is equal to 0 kind of thing we need to write here. Otherwise, we cannot write YE minus YE is equal to 3. Okay. So there is the problem with the PI part. So in this case, what maximum we can do, we can consider YE to be equal to 0. That's all. You know, YE to be equal to 0 and can keep the things like this. Okay, so don't go for it is increasing the power, etc., because we are not using all these things. We are using a typical format to apply it in context of economics. All possibilities, it will be not feasible for us to check. Okay, you got my point?
Yes, ma'am.
So for this typical case, what you can consider, YE you can consider to be equal to 0. And if you consider YE to be equal to 0, you can write the time path as YT is equal to A1 to the power T in this format. And then in that case, if you put the T value to be equal to 0, Y0 is equal to A, and Y0 value is 5, so A is equal to 5. So you can keep it like YT is equal to 5 into 1 to the power T. So keep it like this, YT is equal to 5 into 1 to the power T format. So as you said, it is not 1, rather it is 5. It's a fixed value. So if I present it in this format, you know, PT is given by P naught. So it is fixed at the value 5. Okay, so keep it like this, though, you know, actually, there is some problems when